Have you ever had one of those wild late-night dreams where you somehow create a black hole in your backyard, and then, against all odds, use it as the ultimate, limitless energy source for the world? It sounds like something ripped straight out of a mind-bending science fiction movie, right? Well, buckle up, because this idea isn't just for sci-fi novels or blockbuster films. It's actually a real concept that's been bouncing around in the minds of some of the world's most brilliant theoretical physicists. Let's break down what makes black holes not only terrifying cosmic monsters, but also potentially the most powerful energy sources in the entire universe. First off, what even is a black hole really? Let's clear up some misconceptions. Forget the whole cosmic vacuum cleaner cliché you might have heard in cartoons or movies. A black hole is a region of space where gravity is so intense, not even light can escape its pull. It's like a trapdoor in the fabric of the universe. But there's no magic or fantasy here. It's all grounded in the laws of physics, as strange as they might seem. Black holes warp space-time itself, bending and stretching it so much that anything that gets too close is crushed down into a single, infinitely tiny point called the singularity. That's right. At the singularity, the laws of physics as we know them just break down entirely. It's a place where our current understanding simply stops working. But here's the twist. Black holes aren't just cosmic destroyers. They might actually be the universe's most extreme energy givers. In the 1970s, the legendary physicist Stephen Hawking showed that black holes aren't completely black or silent. Through a wild bit of quantum mechanics, he discovered that black holes slowly emit radiation, now famously called Hawking radiation. In theory, as a black hole evaporates over unimaginable timescales, it releases energy back into the universe. And it's a massive if, we could somehow harness that radiation safely, we'd have an energy source that could outlast stars, powering civilizations for eons. Imagine a power plant that never runs out. But wait, there's more to the story. Around spinning black holes, there's a bizarre region called the ergosphere, where space itself is dragged around at incredible speeds. In theory, if you drop matter into the ergosphere just the right way, you can extract energy from the black hole's spin, a trick known as the Penrose process. Some physicists believe this technique could actually be more efficient than nuclear fusion, which is already considered the holy grail of clean energy here on Earth. It's like wringing pure energy out of the very fabric of space-time itself, a concept that almost sounds like magic but is rooted in real physics. So can we actually make a black hole ourselves right here on Earth? Theoretically, yes, but only on a microscopic scale, far smaller than a grain of sand. In powerful particle colliders, like the Large Hadron Collider in Europe, some scientists speculate it might be possible to create tiny, short-lived microblack holes. These microblack holes would last only a fraction of a second before evaporating in a burst of energy. But if, and it's a gigantic if, we could keep one stable and contained, we'd have something like the ultimate cosmic power plant, right in our lab. Now, for the catch, and it's a big one. You can't just stick a black hole in a box and call it a day. Containing something that can devour matter and warp space-time is a whole new level of challenge. Containment is the stuff of nightmares for physicists and engineers alike. One slip-up, and the black hole could devour its containment system, the entire lab, or, in the worst-case scenario, much, much more. We'd need technology that's basically science fiction at this point. Mind-bendingly strong magnetic fields, next-level radiation shielding, and safety protocols we can't even imagine yet. The engineering challenges are almost as extreme as the black holes themselves. But is it truly impossible? According to the laws of physics, not quite. The door isn't closed. It's just locked with a key we haven't invented yet. So yeah, if you've ever found yourself daydreaming about harnessing a black hole for power, you're not as far off base as you might think. You're actually tapping into one of the most cutting-edge ideas in modern physics. You might just be ahead of the curve, and who knows? Maybe one day, your dream could inspire the next big breakthrough. If you want a deep dive into Hawking radiation, the Penrose process, or how we'd even begin to contain a black hole, drop a comment below and let's explore together. Until next time, keep asking questions, keep dreaming big, and as always, stay curious.